Okay, so on that last long video, when we did the graphing, the mapping, the domain just now, those were discrete graphs, right? Those graphs on the right-hand side were all discrete. They just had points attached to them. So we wrote our domain a certain way, we wrote our range a certain way, and we did a mapping, okay? What we're going to do now is we're going to look at the domain and range of continuous graphs. So on these graphs, notice they're all continuous. They're all connected with points and lines. I can't name just one point and one point. I can't say the domain here is, -1 and 2, because there's all these points and lines connected. So I have to learn how to write domain and range of continuous graphs in a certain way. So here's our hint in our notes that I want you to write. For domain, remember, domain is all your x values. So for my domain, I'm going to scan my pencil left in the negative direction, and I'm going to scan my pencil right in the positive direction. So we're going to scan our pencil left to right and identify the x values in which we are touching the graph. Okay, for range, up and down, I'm going to scan my pencil up all the way, and I'm going to scan my pencil down all the way. So I'm going to go up and down and identify the y values in which we are touching the graph. Okay, so now, last unit, remember we did interval notation and we did inequality notation? Domain and range of these continuous graphs can be written in interval notation and inequality notation. We are going to do them in inequality notation. In Algebra 2, you're going to do them both. So I just want you to know there's two ways to do it, but specific to us, we're going to be doing inequality notation. All right, so let's look at number 1. Here, this graph, if I scanned my pencil all the way left, imagine this line going forever and this x-axis going forever. How far down is this graph going to go? So right here, I know that it's already at -6, but if it goes down further, would this line go all the way to the left? It would, because my arrow. So this is going to the negative infinity direction. And then how far right is this graph going? If I continued on, look at this arrow, it's going to go in the positive infinity direction. So my domain is negative infinity is less than x, which is less than positive infinity. Remember, we've done this interval notation last unit. So negative infinity is less than x, which is less than infinity. Or I could say it's all real numbers. So all real numbers, or you can do it in inequality notation here. But all real numbers, it's understood to be all left and all right. Now, let's look at my range. Okay, so let's do range in a different color. My range starts here at this point, and then if I continue up is my range. So if these lines go up, how far up is it going to go? Well, it's going to go forever. So here, my range, remember range is y, so the variable is y. Y is going to be greater than or equal to, because it's a solid point here. It's a solid point. If it were an open circle, it would just be greater, but it's solid. So y is greater than or equal to 2. And that's it, because it's understood now that it's going to go in the infinite direction. Positive. So y is greater than or equal to, -2, not +2, -2. Okay, so that's how we would write that for number 1. Let's look at number 2. Again, these are all continuous graphs. Let's look at my domain. So my domain is x. Well, how far left does this graph go? It goes to right here. And how far right does this graph go? It stops. So you can see these boundaries. This circle is specific to these boundaries, which I've drawn in blue. And so in blue, that's my x-axis. So that's my domain. It's going to go from -3 is less than or equal x, which is less than or equal to +3. That's what my domain looks like in inequality form, okay, which you're familiar with from last unit, right? Now, my range, how far down does it go and how far up does it go? Notice they stop. It's specific to this range. So my range is -3 is less than or equal to y, which is less than or equal to 3. Okay. Now, I'm not going to lie, these take some practice to get used to writing them in a certain form. So I really do want you spending time doing all these graphs in our notes before you get to the homework. Remember, this is only specific to a continuous graph, not discrete. Discrete domain and range were written with certain numbers. All right, so I'm going to go through these. If you want to pause the video and come back, do that so you can check your answers. So number 3, all the way left, all the way right, all real numbers. My range, if it went all the way down, and it's going to go all the way up, so it's all real numbers. So domain and range are both all real numbers. Those arrows mean it goes on forever. If I look over here, my domain, if I went all the way left, this line is going to continue down, but it goes out. So my domain and range, my domain is all real numbers. And let's look at my range. Does my range, if it goes up and down, it stops at a certain point, and then how far is it going to go down? It's going to go down forever. So I can say y is less than or equal to 1, 2, 3, 4, 5. Y is less than or equal to 5. Okay? And again, if you're not getting these and you have questions, please come and see me in tutoring. All right, number 5. So I can take my line here on my x because there are certain left and right. So that domain's pretty easy to see because it's, stuck. So domain is -1 is less than or equal to x, which is less than or equal to 1, 2, 3, 4, 5. And remember, x is my variable because it's domain. My y value is here, my range. So it's down -3 is less than or equal to y, which is less than or equal to 3. And notice it has to be y because that means range. For this graph over here, domain, it's going to go all the way. It has an arrow, so it would go all the way left, and it would go all the way right. So it's all real numbers. Students see these maximum point and minimum points, and they think, oh, something's going on there. But as far as domain and range are concerned, it doesn't matter. It's still going to go, if you took your range, it's still going to go all the way down and all the way up. So it goes through all of those points. My range can be down to -100, and it can go all the way up to 1,000,000. So all real numbers for number 6. Let's take a look at number 7. This domain, these arrows, mean it's going to continue in the same fashion. So it's going to go all the way left and all the way right. So my domain on number 7 is all real numbers. My range, it only goes up to here and down to here, and it stays between these two pieces. So my range is, remember, least to greatest, so -3 is less than or equal to y, which is less than or equal to 2. That's my range. Number 8, my domain. It doesn't go all the way left. It stops here, but it's going to go in that direction forever. So x is going to be greater than or equal to -1. My range is going to go all the way down, and it can go all the way up, so my range is all real numbers. Okay? All right, let's take a look at number 9 and 10. My domain. My domain is my x value. It's x value all the way here. The only x value it's ever going to be is 2. So x is equal to 2. And my range goes down infinity, up for infinity, so it's all real numbers. Number 10. My domain is, oh wait, I totally lied to you on that one. I got them mixed up. My domain is 2. Okay, so my range here, sorry about that, guys. My domain here is -infinity to +infinity, so it's all real numbers. And my range, it's stuck on -4. So y equals -4. Remember, y goes with range, x goes with domain. Okay? All right, let's take a look at number 11 and 12. how far left and how far right. So look, you got a closed circle here. So at -2, so x is going to be greater than or equal to -2, and then it goes all the way here to the right at 5, but x is less than 5 because it's open circle. Open circle means 5 is not a solution to that. So I go from -2 is less than or equal to x, which is less than or equal to 5 because it stays in between here. Now, let's look at my range. Remember, my range is how far down does it go? It goes down to -2, but it's open circle. So -2 is less than y, and it goes all the way up to +1. So it stays in between here. So y is less than or equal to +1. Okay, so remember, domain left to right, range up and down. On number 12, how far left does it go? It goes all the way here to -4. And how far right does it go? It goes all the way here. So here are my boundaries. It goes between -4 and +5. So -4 is less than or equal to x, which is less than or equal to 5. They're both closed circles, so it does have that equality in there. All right, let's look at my range. How far down does it go? It goes down here. How far up does it go? It goes to here, both with closed circles. So start from least to greatest. So -3 is less than or equal to y, which is less than or equal to 3, 5. Down here to 3, up here to 5. Let's take a look at number 13 and 14. Last one on these examples. So domain, how far left does it go? It goes infinity forever, but it stops right here, and it's open circle. So that's an open circle, so it's going to be x is less than or equal to -3 because it goes this way, less than. And my range, how far down does it go? Infinity. And how far up does it go? 0. So y is less than 0. Well, and that's not less than or equal to. It's just x is less than 2. X is less than 2. Y is less than 0. Okay? All right. Let's see. Last one over here. How far left does my domain go? It goes all the way to -2. So -2 is less than or equal to x. And how far right does it go? It goes to infinity. Or I can just say x is greater than or equal to -2. Okay. My range, how far down does it go? It goes down to -4 is less than or equal to y, which is less than how far does it go? It goes up forever to infinity. So I can say that y is going to be greater than or equal to -4. That's the simplified inequality, and this is the simplified inequality here. Okay, so these are tricky. So if you struggled on these, come in and I can just throw up more problems so you can make sure that you understand them. Remember, this is domain and range for continuous graphs.